Hello and welcome guys. Now in this video we will be understanding the fifth assumption, that is multicollinearity, okay, and how we will be dealing with it. That will also we will discuss, and majorly we will deal with multicollinearity with VIF, that is stand for variance inflation factor. So basically this VIF, variance inflation factor, is measure of multicollinearity in a regression analysis. So multicollinearity occur when two or more independent variable in a regression model are highly correlated with each other, which can make it difficult to determine the effect of each independent variable on the dependent variable. So basically this VIF measure how much the variance of estimated regression coefficient is inflated compared to variance of coefficient if the variables were not correlated with each other. So a VIF of 1 indicates that the variable is not correlated with any of the independent variables, while a VIF greater than 1 indicated some degree of correlation. Generally, a VIF value of less than 5 is considered acceptable, which means that the independent variable is not highly correlated and any other variable in the model. So a VIF value of 5 to 10 suggests moderate correlation, while a value more than 10 till infinity is considered as high correlation. So if the VIF is too high for a particular variable, it may be advisable to remove that variable from the model to reduce multicollinearity and improve the model performance. So that's why I told that VIF is also used for feature selection. So if the VIF is more than 15-20 for any of features that we have, you can directly remove it. So because they are not doing much in our model performance, they are just reducing it. So for example, it is evident that the variable bedroom, okay, has a high VIF, which indicates it is affected by multiple other variable. Along with that, I also inspect that p value of those variable, okay. So since I haven't shown here, but during the analysis I noticed that uh, semi-furnished the semi-furnished variable has considerably high p-value. It was around around 93%. So consequently I eliminated this feature and reconstructed the model with marks of completion, at least some sort of some degree of correlation. So upon further analysis, I have also identified that bedroom. So the bedroom with high correlation it shouldn't be included in our modeling part, as well as the main road. And I mean, I observed that all the VIF are below 5 except the basement. uh, Included for modeling part. I excluded basement because it was having p value of around uh, you know more than 0.05. So I excluded the basement and rebuild the model. Eventually I end up with around 8 features, and which demonstrated also that the VIF is less than 5, as well as the p value is also less than 0.05. So in the later video I will also explain p value in more detail. So that is what I have assessed. And also in summary, VIF is also used to assess degree of multicollinearity in the regression model and help us identify variable that may be redundant or highly correlated with each other, thus providing guidance for feature selection or model refinement also. So let's go to the implementation part and see how we implement it. Okay. Okay, let's come to the notebook part. So here we will be using one simple method. There I will show you how actually high correlation feature look like, as well as I will use stats model library also. So let's see both of them. Okay. Okay, so first of all we need to import our numpy and b, then we'll create a synthetic data with high multicollinearity. Okay, so x1 equal to np dot lean space 1 comma 10 comma 100. Then we'll create two more feature, x2 equal to 2 into np dot random dot normal 0 comma 1 comma 100 points. Same way, just copy the second line and multiply by 3. Okay, now we will check the correlation between independent variable. So to do so, let's first create correlation matrix. Equal to np dot core coefficient, and we'll pass all our arrays x1 x2 x3. Okay, okay, we have created our correlation matrix. Now let's print it. Now you can see that this particular, okay, it's not visible clearly. Okay, yeah, now you can see that uh, here actually they are not much correlating. You can say this is very less correlating, or even not even correlating. Okay, let's rerun it. Okay, let's do a slight change in the formula so that we'll get high correlated feature. So actually we are getting very less value, and that's why the correlation is coming to be very less. So let's multiply x1 with the x2 and x3. Okay, okay, so we have, so you can see now we have high correlated feature. It's like 99%, like 98%, 98%, 99%. So you can see that this particular features are very very highly correlated with x1. Okay, in that case, you remember, right? We shouldn't be taking such features, because I mean either you take x1, either you take x2 x3. It's they are similar. That is what I wanted to show you. Now let's implement it using variance inflation factor from stats model. Okay, so okay, so from stats model dot stats dot outlier influence input variance inflation factor. Okay, let's run it. Now let's set some seed, because we don't want every time running give us different result. Okay, x1 equal to np dot random 100 points, 2 into x1 . Let's copy this code. Now we multiply 3 into same thing, and then our target. Okay, so So what this feature is saying basically, so the x1 is the first predictor variable. It is generated using np.random.rand, so which creates an array of 100 random number uniformly distributed between 0 and 1. It represents a variable that is randomly distributed with no specific relation to other variable, whereas x2 is the second predictor. So basically it is dependent on x1 with a linear relationship, that's why we multiplied, where it is twice x1 plus some random noise added to it. So this create multicollinearity between x1 and x2, because x2 can be predicted from x1. Same way the x3 and y is basically, this is a response variable or dependent, you can say. It can be used for uh, it is generated as a linear combination of x1, x2, x3 with some added noise. To see the relationship, so in summary, this code is used to generate synthetic data with controlled multicollinearity among predictor variables. So this will be helpful for us for testing how multicollinearity affect linear regression model. So let's go ahead and write the further code. So let's create a data frame. Okay, data equal to pd.data frame, or x1 column should get x1 value, x2 column x2, x3. Yeah, so our data frame is created. Now VIF equal to pd.data frame. Okay, we have to import pandas also. Now VIF of variable equal to data.columns. So we are passing values of each of the column. Okay, data dot values one. Now what we will do, we'll print it out. Okay, it is showing shape is not defined. Okay, yeah. So now what you see here is, so we printed the VIF value for each predictor to assess whether the fifth assumption, that is multicollinearity or no or little multicollinearity, is met. So if any predictor has a high VIF, it suggests multicollinearity, indicating that you may need to address the multicollinearity issue, or you can remove it from your regression model, such as obviously by removing it can solve the issue, but we not usually remove every time. We basically handle it with some techniques, by normalizing the values or some other method that we will learn later. So this value that you see is very far larger than the cap, that is 10, right? So basically, you remember we were talking about the control value of VIF. So the control value of VIF should be in between 1 to 10. So 1 indicates that there is no multicollinearity between the predictor variable and other independent variable. In between 1 and 5, it is suggested range for multicollinearity. It implies that the variation of coefficient estimate for that predictor is somewhat inflated due to this multicollinearity, but it may not be significant concern. But if the value of VIF is greater than 5, then it has high degree of multicollinearity, and this suggests that the variance of coefficient estimate for that predictor is highly inflated by multicollinearity, and it led to unstable and unrealistic estimate. So let's see another example with little multicollinearity. Okay, so everything will be same, just copy the this much code. Okay, so what we will change is we'll just change the data. Okay, x1, x2, x3. So here you can just do np.random.rand for all three. Okay, and everything will remain as it is. Okay, now you can see that for all the features our VIF is in between 1 and 5. So you can say that this is not violating our fifth assumption, and we can take these features for our modeling part. So hope this multicollinearity assumption is also clear. So VIF was one of the uh, popular way to check in our data set whether do we have any multicollinearity features or not, but there are many features. Okay, so later on, by moving forward, we will be learning all of those. So in the next tutorial we will be learning about feature uh, you know feature importance. So hope you guys like this video. So thank you so much.